All right, for those of you who weren't able to make it to tutoring today, let me walk you through assignment number 4. So this first question asks us to find polar coordinates of the point that has rectangular coordinates -4, square root of 3, -4. So to convert from rectangular coordinates to polar coordinates, we're going to use r is equal to the square root of x squared plus y squared. So we want this squared plus this squared. So -4 square root of 3 squared is going to be -4 squared is 16 times 3 is 48 plus -4 squared is 16. So r is equal to the square root of 48 plus 16. So that's the square root of 64, which is 8. So if we go up here to our mouse, and we're going to enter 8 for r. All right. Next, to find theta, theta is equal to the inverse tangent of y over x. So here's our y, -4, over our x, which is -4 square root of 3. So those -4s are going to cancel, and we're going to be left with 1 over the square root of 3, which, remember, when we rationalize the denominator, 1 over square root of 3 is the same as square root of 3 over 3. So now you're going to need to look to a unit circle. I have just kind of drawn myself a little unit circle here, but you can go onto the internet and find a unit circle that's going to give you any information you want. It'll have degrees or radians. You can find one that just has the sine and cosine, one that also has a tangent on it. Just look onto the internet, look in Google unit circle, and you should be able to find plenty of examples for that if you don't have the unit circle from your notes in class. All right, so theta is equal to the inverse tangent of 1 over the square root of 3. And if we look on our unit circle, there's 2 places where the tangent's equal to 1 over the square root of 3 or square root of 3 over 3. That's at 30 degrees and at 210 degrees. And the way that we tell which one we want is, notice that this, in rectangular coordinates here, we're going -4 square root of 3 and then -4. So we're going back and then down. So we're going to be down here. Remember, if we've got our quadrants here, we're going to be down here in quadrant 3. And so we want to look for the angle that's going to put us in quadrant 3. And that's going to be 210 degrees. So let's enter 210 degrees there. And that is the correct answer. All right, so let's clear that and move on to number 2. All right, find polar coordinates of the point that has rectangular coordinates 1 and -1. All right, so r is going to be equal to the square root of 1 squared, which is 1, plus -1 squared, which is also 1. So this is going to be equal to the square root of 2. And we can enter that over here. By the way, this one can't be reduced, but if you have something that that could be reduced, like the square root of 50 can be reduced to 5 square root of 2, you don't need to reduce that. You can enter it in as square root of 50, for example, and it'll tell you that, you know, that could have been reduced, but it'll still accept that as a good answer. All right, moving on. Theta now. Theta is going to be equal to the inverse tangent of -1 over 1, which is -1. And looking on our unit circle, we find where tangent is equal to -1. Well, that's equal to -1 at 135 degrees and also at 315 degrees. But again, we look at which quadrant we're going to be in. And if we go out 1 and down 1, we're going to be in this quadrant down here, number 4. And so that's going to give us 315 degrees for our answer there. 315 is the angle that gives us a tangent of -1, and that is in quadrant 4. All right. Number 3. Find polar coordinates of the point that has rectangular coordinates -3, 3 square root of 3. So again, r is equal to the square root of -3 squared, which is 9, plus 3 square root of 3 squared. Well, 3 squared is 9. Square root of 3 squared is 3. 9 times 3 is 27. So this is going to give us the square root of 9 plus 27. That's the square root of 36, which can be reduced. 36 isn't a perfect square, so we can't get this to an integer, but we could reduce that down to, what would that, well, actually, 36 is a perfect square. That's going to be 6. So r is going to be 6. And then theta is going to be the inverse tangent of 3 square root of 3 over -3. So it's going to be negative square root of 3. And negative square root of 3, if we look on our unit circle, that's going to be at 120 degrees and 300 degrees. But we want the one that is going to be, if we go -3 and up 3 square root of 3, we want it to be in this quadrant 2 here. So that's going to be 120 degrees. All right. Now we're going from polar coordinates to rectangular coordinates. So here we have that x is equal to r times the cosine of theta. So we first need to find x, and that's equal to r, which is -3, times the cosine of our theta, which is 5 pi over 4. I'm really not good at writing with a mouse, but giving it a shot here. All right, so cosine of 5 pi over 4, if we look at our unit circle, we go to 5 pi over 4. The cosine is negative square root of 2 over 2. And if we multiply that by -3, so we want -3 times negative square root of 2 over 2. And so that's going to be positive 3 square root of 2 over 2. So let's go over here and enter that as the square root of, we want 3 square root of 2, sorry, over 2. So 3 square root of 2 over 2 is going to be our answer there for x. And then for y, we want, that's going to be equal to r, which is -3, times the sine of 5 pi over 4. Oops. And the sine of 5 pi over 4, if we look at our unit circle, that's going to be also negative square root of 3 over 2. And so this is going to, y is going to be the exact same answer. So let's enter that same thing. 3 square root of 2, whoops, divided by 2. All right. Number 5. Find the rectangular coordinates of the point that has polar coordinates 2, 5 pi over 3. All right, so x is going to be equal to r, which is 2, times the cosine of negative 5 pi over 3. And the cosine of 5 pi over 3, we go to 5 pi over 3, the cosine of that is 1/2. So, negative 5 pi over 3, that's going to be the same as, 2 pi over 3? No. Yeah, 2 pi over 3. We added 2 pi to this. That's the same as 5 pi over 3, negative 5 pi over 3 plus 6 pi over 3 would pi over 3. So we want pi over 3, sorry. So negative 5 pi over 3 is the same as pi over 3. And the cosine of pi over 3 is 1/2. And 1/2 times 2 is just 1. Okay, so our x is 1. And then y is equal to 2 times the sine of negative 5 pi over 3. And again, negative 5 pi over 3 is the same as pi over 3. And the sine of that is going to be square root of 3 over 2. Square root of 3 over 2 times 2 is just going to be equal to the square root of 3. And so we can go over here and enter the square root of 3. All right. Last one. Find the rectangular coordinates of the point that has polar coordinates -3, 3 pi over 4. So x is going to be equal to r, which is -3, times the cosine of 3 pi over 4. So 3 pi over 4, the cosine of that is negative square root of 3 over 2. Negative square root of 3 over 2 times -3. So it's -3 times negative square root of 3 over 2. So this is going to be positive 3 square root of 3 over 2. So 3 square root of 3 divided by 2. All right, and then y is going to be equal to -3 times the sine of 3 pi over 4. And the sine of 3 pi over 4 is positive square root of 2 over 2. Sorry, I messed something up here. I couldn't read my squiggly writing. This is square root of 2 over 2. Let's go fix our answer over here. This should be square root of 2. And the sine is going to be positive square root of 2 over 2. So this is going to be the same answer, only negative. This -3 times positive square root of 2 over 2 is going to be negative. So -3 times the square root of 2 divided by 2. All right. Notice here it says their answer is correct. However, you could also write the answer with a negative sign in front of the fraction. So we could have put our negative sign out front here. It really doesn't matter whether we put the negative sign out front or in the numerator. It still gave us credit for the answer. All right, so that's assignment number 4. Hopefully that helped. I will also do a video for assignment number 5.